Okay, this is the chapter 7.3 to 7.5 quiz review. You have a photocopied worksheet, so you don't have to draw all this and write all the letters down. So on number 1, you see overlapping triangles. So number 1 is overlapping triangles. I would like you to write that on your sheet. And then we're going to just make some observations. We're going to tell everything we know about these figures, and then we're going to try to use, as it says on your photocopied worksheet, we're going to try to say something about the AA, SSS, or SAS similarity postulates. So angle, angle, side, or side, side, side similarity postulates. And if we can, we'll say something about scale factor as well. Okay, so when we look at this, we know that AB is parallel to DE. And I'm going to extend those out and make those lines. And then these parallel lines are frequently cut by a transversal. There's actually 2 transversals you can have. You can either have AC, so AC can either be a transversal, and if you prefer, and I'm going to use a different color, you could use BC. They're both transversals. And we know back from chapter 3 that when you have 2 parallel lines that are cut by a transversal, then there are going to be things that are true about their angles. So for instance, these angles right here, cut by the transversal AC, this one here and this one here, they lie in corresponding positions on the transversal. They're both above the parallel lines and to the right of the transversal. So those are corresponding angles, are congruent. So angle BAD is congruent to angle, so BAD is congruent to angle EDC, and that's because they are corresponding angles. And the same thing holds true if you come over here. We'll use a different color. For this transversal BC, it's still cutting AB, lines AB and DE. So this would be to the left of the transversal, both above the parallel lines, or excuse me, both below the parallel lines. And so angle ABE is congruent. I forgot a congruent symbol on this other line. Okay, ABE is congruent to DEC, or CED. And again, that's corresponding angles. That's the reason. Now, we've already proven the AA theorem, angle-angle theorem. So if I have 2 angles, these would be similar triangles because of the angle-angle similarity postulate. I didn't have to prove both of those corresponding angles, although I can. I could have also used this angle C. They're overlapping triangles. Let's get a different color, which is green. This angle right here, C, is going to be the same angle for both triangles. So angle C is congruent to angle C. It's a shared angle. So I could have also used the shared angle C as well, and done the angle-angle similarity postulate. This triangle, let's just make sure we write this. We have triangle ABC, and the similarity statement would be triangle ABC is similar to triangle DEC. Make sure you match up your corresponding parts. Okay, so there we go. Angle ABC, ABC, and then we match up corresponding parts. It's similar to triangle DEC. Okay, now we're moving on to the next triangle. I should have said the next pair of triangles. These look like a little bow tie, and you have to be kind of careful with these. We have some things that we can actually just talk about right away, which is MO is parallel to PO. I'm going to create lines with these because I'm going to do something with that information. So I'm going to create lines, extend those out. So line MO is parallel to line PO. And then there are two transversals here. It's a little bit confusing. You have to ignore that little X in the middle. But I'll use one color for one transversal. We'll start with that. So if I have this transversal right here, MO is a transversal. There will be another one. Before I put that other one in, let me just go ahead and use the transversal. So you have two parallel lines, the two red lines, being cut by the transversal. Ignore that other line, OP, that's our other transversal. You have this angle in the triangle, and you have this angle in this triangle over here. So this transversal, if you look at it, let me highlight. You can see there's the transversal. They are on alternate sides of the transversal inside. Both of them are inside the parallel line, so it is alternate interior angles. So angle, let's do NMO is congruent to angle NOP, and that is because of alternate interior angles. So we have one angle. We actually don't need to find the other alternate interior angle, but I want you to be able to see it. So this time, let's use a highlighter. I think it'll be easier. So if we need a fine tip. So this is also a transversal right here, which means that this angle, this one MON, will be congruent to this angle here. So angle MON is congruent to angle OP, or let's go NPO. Those are on alternate sides of the transversal inside the parallel line. So once again, it's alternate interior angles. At this point, we could say that we have proven that these two triangles are congruent based on the angle-angle postulate. But let's do one more. Let's use orange. Oh. So we also have these angles here. They are directly across from the bow tie, if you will. So angle MNO, got to have N in the middle, is congruent to PNO, or ONP, as long as N's in the middle. And the reason that they are congruent is they are vertical angles. Again, another chapter 2, chapter 3 idea. So you have to keep those things in your head. All right, so we've done more than we needed to, because to do the angle-angle similarity postulate to prove similarity, we just would have had to have two angles, and we ended up showing that there were three that were congruent. And then I want to show something else in just a moment. So let's go ahead and write that similarity statement. So just do triangle, and let's go MNO is similar to triangle. Now we know that N is going to have to be in the middle, but this is where some students get a little messed up. What parts correspond? So let me go ahead and highlight. I've used the yellow highlighter, so let's go ahead and use the blue one. This part, let me use a bigger tip too. This corresponds to this. So MN corresponds to NO on the larger triangle. And let's do the green. This one on the larger triangle, NP, corresponds to ON on the smaller triangle, which means that if we go MNO, we have to go, M would correspond to O, so it would be ONP. That's how you write your similarity statement, and it's similar because of the angle postulate. Two angles are congruent, so therefore it is similar. Now keep in mind, to be a similar figure, in this case it's triangles, to be similar figures, similar triangles, all the angles have to be congruent, and then the sides of your figure have to be proportional. Okay, moving on to the next figure. Okay, as we look at this next one, I didn't give you any angle measures, and they don't share any angles, so except for this E right here, but we're not given any angle measures per se, so we're not going to be able to comment on angle measures. What we can look at for is to determine similarity between CDE. We're going to be looking to do similarity between triangle CDE and triangle EFG. Is we can look for proportionality in their sides, and so we're going to go ahead and do that. And when I say proportionality in their parts, I mean proportionality in their corresponding parts. So I'm going to go ahead and highlight their corresponding parts. So we're going to use this 8 and this 12 will be corresponding parts. That's easy to see. So CE corresponds to EG. CE is 8, and EG is 12. And you can also call this figure A and figure B if you wanted to. So you could also just say A and B, A being the smaller one, or you could label them with the segments. It doesn't matter. Simplifying that, 4 divides into both of these. 4 goes in twice, 4 goes in 3 times. So the ratio for the first one is 2 to 3. We're going to see if that is in fact the scale factor. So now let's go ahead and highlight CD and EF. So CD corresponds to EF. CD corresponds to EF. And then that's figure A to B. You could do either one. You don't have to do both. I'm just showing you how you could go about doing this. CD is 10. And EF is 15. And these are both divisible by 5. 5 goes in twice. 5 goes in 3 times. So far, so good. And in fact, we're completely finished because you've got an isosceles triangle here. You've got 2 sides the same, 2 sides the same. So in this next one right here, let's use the green highlighter color. ED and GF. So for figure A and B, that would be ED and GF. ED is 10, GF is 15. We already know that's 2 over 3. So the scale factor equals 2 over 3. And once you have a scale factor, then you know that the sides are proportional. So you don't have any angles given. So this is the yes triangle. We're going to go in the proper order. CDE, matching up corresponding parts, is similar to EFG. Triangle EFG, and we know that because the corresponding parts are proportional, meaning they have the same scale factor. So side, 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 similarity postulate. So again, side, side, side similarity postulate is why they are similar, because the 3 sides are proportional, meaning they have the same scale factor.